Hi guys, welcome to this video on expanding the brackets. I want to demonstrate what I mean by expanding the brackets with a simple numerical question. So I want to demonstrate it through the product of 3 times 11. If we look at a single rectangle that has dimensions 3 units by 11 units, we know we can find the area by doing 3 times 11. Okay, so 3 multiplied by 11, we know what the area of that rectangle will be. But if we split up this 11 into two different numbers, 7 and 4, we know that that distance would be 7 and this distance would be 4. The area of this smaller rectangle, so we started with a larger rectangle and now we've got two smaller rectangles. The area of this one will be 3 lots of 7 and the area of the yellow rectangle will be 3 lots of 4. So 3 times 11 can be expressed as 3 multiplied by 11, and I'm writing 11 in this way. 3 times 11, 7 and 4. So 3 times 11 can be expressed as this value, which is 3 times 7 plus 3 times 4. So if we look at this expression to this expression, a nice way of writing our answer is 3 multiplied by 7, then 3 multiplied by positive 4. So 3 times 7 plus 3 times positive 4. And we know that these two answers would be 3 times 7, 21, plus 3 times 4, which is 12. And our final answer, we already knew this was 33, but we expressed it as the sum of two different products. Now, we know how to do 3 times 11 with this expansion, but what about 3 times x plus 4? So I've pretty much replaced this 7 with an x. So if I create another rectangle and break it up into two smaller parts, so here's my 3 multiplied by x plus 4. If that total distance or that total length is x plus 4, that is going to be my x and this is going to be my plus 4. The area of this is 3 times x, 3 multiplied by x, and the area of this rectangle is 3 multiplied by 4. So 3 times x plus 4 is equal to 3 times x plus 3 times 4. So 3 times x plus 3 times 4 is the same as 3x plus 12. So here's my expansion to this expression. So here's my product and here's my expression. Now what happens if we extend it to a particular area with larger products? So if I had 11 times 15 and I broke up my 11 with 7 and 4 and my 15 as 10 and 5. I could do this a multiple arrangement of ways, so I could do 14 and 1, but I just chose 10 and 5 just to illustrate this example. So the area of these four parts, these four rectangles, will be 10 times 7, which is this, 7 times 5, which is this, 4 times 10, and also 4 times 5. I've said it in a different way, so I said 7 times 10, but I could also have 10 times 7. Okay? So 15 times 11, if I just do that on the calculator or know that product, it's 165. And I'm going to express this 165 with the sum of those 4 rectangles, because 11 times 15, which is 165, will be the same as the area of the 4 rectangles. So this binomial expansion is going to be equal to this expression on the right hand side. So how do we get this expansion from here? So the product of those two, which is 15 times 11, 15 times 11, that's the same as 10 times 11, so 10 times 11. So I'm looking at this rectangle here, which is 10 by 7 plus 4. 10 multiplied by 7 plus 4. And this section here is the area on the right hand side, which is going to be 5 lots of 7 and 4. 5 lots of 7 and 4. From our previous question, by expanding the brackets, we have 10 times 7 and 10 times positive 4. So 10 times 7 plus 10 times 4. And then I got plus 5 times 7 and plus 5 times 4. And this works out to be 70. This works out to be 40, this works out to be 35, and that works out to be 20. Find the sum of those 4 numbers, and it works out to be the same as what we started at the beginning, 165. So the product, so this particular expression here, is called a binomial expansion. Why it's called a binomial expansion? Binomial means 2 terms. Bi as in 2, nomial as in terms. If I had 3 terms in the brackets, that would be called a trinomial. More than that will be called a polynomial. Like a polygon with many sides, a polynomial is many terms. So binomial means 2 terms, and we've got a product of 2 of them, so binomial product or a binomial expansion. Now let's look at the binomial expansion with pronumerals in it. So if I had x plus 5 multiplied by x plus 4, I would have the area of these 4 rectangles. So x plus 5 multiplied by x plus 4 is the area of those 4 rectangles. So the first one is x times x, x multiplied by x. This one here is 5 times x, which is 5x. This one is x times 4, or 4 times x, and 4 times 5. So the product, or the binomial product, is going to be x multiplied by x plus 4, x multiplied by x plus 4, plus the area of this rectangle, which is 5 lots of x plus 4. 5 lots of x plus 4. X times x is x squared. X times 4 is 4x, plus 5 times x, plus 5 times 4. Looking at the 2 middle terms, 5x plus 4x, or 4x plus 5x, is 9x. So then we have x squared plus 9x plus 20. And here is our final solution. So this binomial product, in this case, gives us an answer of a trinomial. Okay, without drawing rectangles, we'll illustrate how to expand the following binomial product just through algebraic means. So x multiplied by x minus 3, x multiplied by x minus 3, plus 4 lots of x minus 3. So the expansion here will be x times x times negative 3, positive 4 times x is positive 4x, positive 4 times negative 3 is negative 12. Look at the two middle terms. Negative 3x plus 4x is going to be a plus 1x. Now this plus 1x, of course you don't have to have the plus 1, so we just leave it as plus x. So the way we do this without always drawing a rectangle is get the first term, put that at the front, and multiply it with the brackets in the second set of brackets. Then get the second term in the first set of brackets, and then multiply it with the second set of brackets again. So it's x multiplied by the second set of brackets and 4 multiplied by the second set of brackets. Okay, pause the video and looking back at our first example, follow the process to finding the expansion of this binomial products, and then we'll see how you went. So pause the video and we'll illustrate what the answer is in a minute. Okay, so you should get 3a multiplied by the second set of brackets minus 2 multiplied by the second set of brackets. Then we do 3a times 2a, 3a times positive 4, negative 2 times 2a, and then negative 2 times positive 4. So we end up getting that expansion was 6a squared, 3a times 4 is 12a, negative 2 times positive 2a is a negative 4a, and then a negative 2 times a positive 4 is going to be a negative 8. Look at your two middle terms. Now this doesn't always happen. The two middle terms don't always simplify, but if they're in terms of a's or both in x's, so like terms, we can simplify that. So that simplifies to 8a. So 6a squared plus 8a, take away 8. Okay, these questions are for you to do, so pause the video. We've got two questions at the start just by expanding the brackets with one term at the start, and then question 4, binomial products with two terms in each set of brackets. So pause the video, answer them, and then I'll illustrate the answers in a minute. So 4 times b is 4b, 4 times negative 9, negative 36. Negative 4x multiplied by x is negative 4x squared. Negative 4x times negative, so double negative, is a positive 4xy. M multiplied by the second set of brackets, negative 2 multiplied by the second set of brackets, m times m is m squared, m times negative 6, negative 6m, negative 2 times m, negative 2m, negative 2 times negative 6, watch out for that double negative, and 2 times 6 is 12. Simplify the two middle terms, and here's our final answer. M squared minus 8m plus 12. Okay, 3m times that, negative 4 times that, so 3m times 6, 3m times negative 2m, 4 times 6, sorry, negative 4 times 6, and negative 4 times negative 2m. So 18m, take away 6m squared, take away 24, plus 8m. These are the like terms. So they work out to be 26m, take away 6m squared, take away 24. Now we have no more like terms, so that final trinomial is our solution. That's our final answer. So mark your work, see how you went, and if you have any questions, please review that video, and if you still are unsure, please ask in class. Thanks for watching the video.